All right, day one of this week, some review on trig identities. These 6 trig identities right here, we will be using these today, and we're just reviewing them on how to use them in a triangle. Again, all of these have to do with the unit circle, and we've seen that before, but now is more about solving. Now is more about can you find the actual value given a triangle. All right, let's do this. So here we go. Again, we have sine, cosine, tangent, cosecant, secant, cotangent. And those go with the corresponding ones like you see here. Sine, cosine, tangent. All right. And then this will obviously help us as well. Sine, cosine, tangent. Sine is opposite over hypotenuse. And then cosecant would be hypotenuse over opposite. And then we'll see that here. Here's my triangle. It's a 3, 4, 5 right triangle. If you remember that special right triangle, 3, 4, 5. I need to find all 6. So we'll start with sine of theta. Again, here's theta. Sine of theta. What else? We have cosecant theta. Those go hand in hand. We have cosine theta. We have secant theta. Those go hand in hand. And we have tangent theta and cotangent theta. Those go hand in hand. Let's start with sine. Sine is opposite over hypotenuse. Here's opposite, 3. And then my hypotenuse is always across from my right angle, which in this case would be 5. So 3 over 5. 3/5. Okay, that's fine. Sine of theta is 3/5. Cosecant. Cosecant is hypotenuse over opposite. So this would be 5/3. And we want to leave it as a fraction, so 5/3 is fine. Cosine. Cosine, a over h, adjacent over hypotenuse. Here's theta. We said that this one was opposite. This 3 was opposite. 5 was hypotenuse, which means 4 is adjacent. So this would be 4 over 5. And then the secant would be the reciprocal of that, 5 over 4. Again, you can leave it as a fraction. Please don't make it a decimal. Just leave it as a fraction. Tangent. Tangent, opposite over adjacent. Opposite was 3, adjacent is 4, so my tangent is 3/4. Cotangent would be the reciprocal of that, or 4/3. Okay. We do have ways of actually solving here for theta, but we're not trying to find that right now. All we're trying to find is that ratio, and the ratio obviously means a fraction. So this word ratio right here means fraction. Okay. And that's what we did. We have 6 fractions. We have 6 trig ratios, just using this 3, 4, 5 right triangle. Here, we'll do this one. Find each of the 6 trig ratios. Notice each quadrant of this triangle is in. What does that tell you about the signs? All right. This is like a coordinate grid. So you got to think, here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. Because we're in quadrant 4, this is positive, and this side will be going down, so this would technically be negative x. We're not sure what that is yet, but technically it would be negative x, but we can't have a negative distance. So because of that, you can think of it as the absolute value, but we can leave it as negative x just for the sake of having it. All right, we don't know what it is yet, but we can still write the ratios. Sine, cosine, tangent. Let's see what colors I used up here. Blue, red, black. Okay. Blue. Sine of theta equals, we also have cosecant of theta equals, and then red, we have cosine of theta equals, we have secant theta equals, and then black, we have tangent theta, we have cotangent theta. Okay. Here is my theta. Let me find sine, cosine, tangent. Sine, I always like to just write it on the end, so I don't mix it up. So is sine is opposite over hypotenuse. Okay, here's theta. Opposite would be negative x. Hypotenuse is always across from the right angle, which is 13. That's a fun pen. So I have x over 13. Okay, so negative x over 13, sure. Cosecant would be the reciprocal of that, or 13 over negative x. Cosine. Right? Adjacent over hypotenuse. This would be 5 over 13. And then secant is the reciprocal, which is 13 over 5. Okay. And then tangent. Tangent, we have opposite over adjacent. Opposite would be negative x over adjacent would be 5. And then cotangent is the opposite, or the reciprocal of that, excuse me, which is 5 over negative x. All right. So I can actually write these here too. I'll write it in shorthand here. All right, so let's look at these a little bit more. We have sine is positive, or excuse me, sine is negative. If you look here, we have a negative divided by a positive, so sine is negative. Cosine is a positive divided by a positive, so cosine is positive. And then you could see here, tangent would be negative as well. So does that correspond with our unit circle? Again, this is a coordinate grid and our triangle is in the fourth quadrant. Does that correspond with our unit circle? Well, the fourth quadrant of my unit circle, I know I've already written on this, but you could see, for instance, this one. This is my fourth quadrant. Remember, it's cosine, comma, sine. So cosine is positive, sine is negative, positive, negative. Does that correspond up here? Yep, cosine is positive, sine is negative. Therefore, we did it correctly. All right, so you can go ahead and finish some of the rest of these. Remember, make sure you know what quadrant you're in. This one is quadrant, that's 1, that's 2. This would be quadrant 3. This one is, there's 1. This is 2, so you're in quadrant 2. All right, so make sure you are looking at those. All right. That's all for today. I told you a pretty short video, about 10 minutes here. Go back. You can always pause. You can always rewind it. Anything like that. I know I run through these kind of fast, but feel free to watch them over and over and over again until you completely understand. All right, I'll see you guys tomorrow.